This is a key to worksheet number 9, and in this case, again, we're solving square root equations. Notice, though, that in these two problems, we have variables on both sides. So we have a variable here and a variable here. Same thing here. So we're going to need to be a little bit more careful with these problems versus one in which the variable only appeared in the radicand. So again, just as before, whenever you solve a square root equation, you want to make sure that the radical is by itself. So if we look at number 1, I'm going to go ahead and rewrite number 1 over. Let me go ahead and do that here. So number 1, we have x minus 3 equals the square root of x minus 1. So remember, the idea when solving a square root equation, the first step is to get the radical by itself, and you do. The next step is to get rid of that square root symbol. So all you have is the radicand. Now notice that the index is 2, so square root. The opposite of squaring is to square. But what I do to one side, I have to do the other. Now you need to be a little bit careful here. You got to put this in parentheses because you're squaring this left side, and that left side is a binomial. Okay? All right, so now let's see what we have. We have x minus 3 times x minus 3, right? Equal, and on this side, the square root and the square onto each other. It's kind of like saying the square root of x minus 1 times itself. And so this, whenever you have the square root of a radicand times the square root of that same radicand is just a radicand. So on this side, you just have x minus 1. Now, notice on this side, you're multiplying two binomials, so you're going to have to use the FOIL method. And so when I FOIL this out, first times first, so x times x is x squared. The outer is a negative 3x. The inner is a negative 3x. Now remember, whenever you square a binomial and you use FOIL, the outer and the inner will always be the same. And then the last, a negative times a negative is a positive, and then 3 times 3 is 9. And that's going to equal, on this side, x minus 1. So notice when I FOIL this, I ended up with a quadratic equation. See, this is quadratic. It is not linear. It is quadratic. Okay? So let's combine like terms on the left. So I get x squared, negative 3x and negative 3x and negative 6x plus 9 equal x minus 1. Now, we got to solve this quadratic equation. Notice this is quadratic now. That's a quadratic equation. Okay, so we got to put it in standard form. So when I put this in standard form, I'm going to subtract x from both sides. And notice I'm aligning my like terms. What you do one side, you do the other. And so I get x squared, a negative 6x and a negative x is a negative 7x plus 9 equal x minus x. That has to be 0. And so 0 to negative 1 is a negative 1. So again, standard form is where you have 0 on this side. So now I've got to add 1 to both sides. And notice I'm aligning my like terms. And so I get x squared minus 7x plus 10 equal 0. Okay, now I've got to solve this quadratic equation. So the next step is to factor. And so in this lesson, remember in this lesson, we haven't talked about the quadratic formula yet. So these problems are factorable, okay? All right, so when I factor this, I get, notice the last sign's positive, so these signs are the same, it'll be negative. So we're going to get x minus 5 times x minus 2. All right, and then if I solve for, if I set each factor equal to 0 using the zero factor property, I get this, x minus 5 equals 0. X minus 2 equals 0, and then notice I went from a quadratic equation, remember that quadratic equation we had earlier, which was x minus 3 equal the square root of x minus 1. So I went from a quadratic equation to a square root equation to a quadratic equation to two linear equations. So I get x to be 5, x to be 2. Now, here's the situation. Whenever you raise both sides of an equation to an even power, you need to check your solutions in the original. Especially if you have variables on both sides. You see, I had a variable on this side. So I need to check to see if both of these actually are solutions to the original. So x equal 5 and x equal 2 are solutions to this quadratic equation, but the question is, are they both solutions to the original? And so remember, that's where whenever you square both sides, you may introduce extraneous roots or solutions. So, either both or one could be false solutions. They may not be solutions to this. So you got to check. All right. So you got to show that work though. You got to show that you checked this. That's part of that process. Okay. So here's the original. So let's check the first one. X equals 5. So I get, in my original problem was this. And so wherever we see the variable x, I'm going to substitute 5. So 5 minus 3 equal the square root of 5 minus 1. So the question is, are those two sides equal to each other? Well, 5 minus 3 is 2. This right here is the square root of 4. And so, yes, they are equal because the square root of 4 is 2. Oops. Square root of 4 is 2. So they are equal. So 5 works. Okay, and let's check 2. So x equals 2. So same thing, the original problem, x minus 3 equal the square root of x minus 1. So I get 2 minus 3, and I want to see that's going to equal the square root of 2 minus 1. Well, 2 subtract 3 is a negative 1. The square root 2 minus 1 is 1, and the square root of 1 is 1, and that is not true. Okay? So what that implies is that x equals 2 is extraneous. So it's a false solution. It's extraneous. Extraneous is a false solution. So the only solution to the original problem, meaning this right here, the only solution to this, so the only solution to x minus 3 equal the square root of x minus 1 is x equals 5. Okay? All right, so that was number 1. Let's look at number 2. So number 2, we have this equation. So we have the square root of 3x minus 5 equal x minus 3. So again, the first thing you have to do is get the radical by itself. And it is already in this case. So the radical is already by itself. But notice there are variables both sides. You see that? So at some point, I need to check for extraneous roots. You have to check when you have variables on both sides. Okay. Now let me go ahead and rewrite this over. So the first step is to get the radical by itself, which already is. The next step is to get rid of that square root symbol. So the opposite of square rooting is to square. So I'm going to square both sides, just like this. So you put this side in parentheses squared, you put this side in parentheses squared. Now remember, on the left side, what you have here is this, the square root of 3x minus 5 times the square root of 3x minus 5. Well, that's just the radicand 3x minus 5. And so remember, the square root and the square will undo each other. Those are inverse operations, so that's why it's just 3x minus 5. That same idea here. Equal, now here I'm squaring a binomial, so let's do that work. So when I square that binomial, x minus 3 times itself, and FOIL it out, I get x times x is x squared. The outer is a negative 3x. The inner is a negative 3x. The last, a negative 3 times a negative 3 is a positive 9. And so I get x squared, a negative 3x and a negative 3x is a negative 6x plus 9. So that's this. X squared minus 6x plus 9. All right, now notice I went from a square root equation to a quadratic equation. So I'm going to put this in standard form. So let's bring everything to this side. So you want 0 over here. So I'm going to subtract 3x on both sides, just like this. And so when I combine like terms, that's 0 here. So I get a negative 5 equal x squared, a negative 6x and a negative 3x and negative 9x, and then plus 9. And I'm going to add 5 to both sides. So notice I'm aligning my like terms. Combine like terms, I get 0 equal x squared minus 9x plus 14. Okay? All right, now let's go ahead and factor this because you want to solve this equation now, so you got to factor. So when I factor this, I get x minus 7, x minus 2. And so now I'm going to say each factor equal to 0, so I get x minus 7 equals 0, x minus 2 equals 0. So notice I went from a quadratic equation to 2 linear. And so I get x equals 7, x equals 2. Now, you need to be careful. You just solved a square root equation by raising both sides to an even power. So again, you need to check for extraneous roots. Check for extraneous roots. Okay, so basically see if any of these is false. That's what you're asked to do. Okay, so they may both work, they may both not work. One may work. One may be a solution. So I always go back to the original problem. So let me go ahead and rewrite the original problem. The square root of 3x minus 5 equal x minus 3. So let's check the first one. Let's check x equals 7. So I receive the variable x and substitute 7. So I get the square root of 3 times 7 minus 5, and I'll receive that's going to equal 7 minus 3. Well, 3 times 7 is 21, so that's the square root of 21 minus 5. The square root of 21 minus 5 is the square root of 16, and the square root of 16 is 4. Over here, 7 minus 3 is 4, and yes, they are equal. So I know that's going to work. Now let's check this one. So let's check x equal 2. So when I check x equal 2 in the original problem, which is this, the square root of 3x minus 5 equal x minus 3, I get the square root of 3 times 2, subtract 5, and again I want to see that's equal to 2 minus 3. Well, 3 times 2 is 6, right? And so that's 6 minus 5, and 6 minus 5 is 1, and the square root of 1 is 1. 2 minus 3, 2 subtract 3 is a negative 1, and those are not equal. So what I found is that x equal 2 is extraneous. Okay, so that means that x equal 2 is a solution to this quadratic equation, but it's not a solution to the original. It's a false solution. And so the only solution is x equal 7. Okay? All right, so that was the work for number 2. So number 1, we could just go ahead and write the work is on other page. All right, and so that is the key to worksheet number 9. That's the key to worksheet number 9.